Hello, my dear JEE warriors. Welcome aboard to the final examination. So JEE Advanced is over, but still couple of exams remaining. Maybe your second phases of BIT, SAT, and so much more. And one of the most important exams, yes, your next exam, through which you can get into, Atomic Research Institute or even in NISA. So a lot of research oriented students give this examination. Already made a detailed strategy video on that. And you should also understand that the level of questions are much more superior than JEE mains. So if you think you have cracked BIT SAT, VIT, mains, let me tell you, they are not even like advanced questions, but not like mains questions. They are slightly different. They are going to test your aptitude towards research rather than just different patterns of question. The question pattern is simple like MCQs, but how are you able to analyze those situations in a research environment? That is what they check, and you are going to love those questions. So I've got to use some of the amazing PYQs of the last 2 years so that you too can level up. And if you want more such sessions, let me know quickly in the chat box and also in the comment section. Ready, guys? Audible, visible? Yes, this is for the next 2025, and we will conduct more such sessions if you want to. Okay. So you guys have liked the session? Yep. Done. Ready? So we'll be focused completely on the session. All right. So I won't be entertaining too many doubts because the session is going to be quite intense. So be prepared for that. Like the video. Yep. Done with the subscription. Have you subscribed to the Vedantu J English channel? Done. Okay. Cool. So let's begin. Here it comes, the first question on your screen. It says that this is 2024 question. A solid object is dropped from a certain height under the influence of gravity. The object is experiencing some drag force. Okay, fair enough. And the magnitude is proportional to the square of the speed. Assume that the force is negligible. The gravitational force but contributes towards the heating of the object, the rise in the temperature just before it reaches the ground. See, there are a couple of important things that you should keep in mind over here. The object is dropped, it is experiencing two forces, gravity and the resistive force. The resistive force is proportional to the square of the speed, okay, and the drag force is small as compared to gravity. So the major force is gravity, but when that resistive force acts for a long time during that fall, eventually the body gets heated. So that heating is coming because of the resistive force. So couple of things now that I can do over here. First things first, since our drag force is much smaller than the gravitational force, so the acceleration will be g only. Therefore the velocity, simply put, will be a root of 2g into h. Velocity will be simply put root of 2gh, non-negotiable. Okay, gravity only is playing a major role. There is no role of drag force in it. That is as per the given conditions only. The drag force is negligible. But towards heating, it is contributing. So maybe we can use that fact that it is heating it. So let's say for a small displacement, the heat which will be produced will be obviously dq. That dq heat will come from the resistive force. So it is the work done by the resistance, by that particular resistance. So the work done goes into heat. The work done is the force of the drag force into the displacement, which I can call it dx. And this dq will be mass into c into a small change in the temperature. Now I can write dt as this m and c will go below. This dx will be as it is. Well, what is this drag force? It is clearly mentioned in the question. The drag force is proportional to the square of the velocity. The drag force is proportional to the square of the velocity. So some k into v square, k, some constant. How do we care? We don't have to worry about it. All right. So now if I integrate this, so integral of dt, k is a constant, mc is also a constant, And what is V square? V square will be nothing but 2G into H, but actually it will be 2G into X, you can say, if X is the height by which it has fallen. Or if you don't like this dx, you can also replace this dx by that small displacement, which will be dh. Dh is that small distance, that small displacement which is there, that will be dh. So that will be better to integrate. Anyways, the square of this particular velocity, I get it from here because I know v is root 2gh. So square of it will be just 2gh, and that dh will remain over here as it is. And of course, we have to integrate this. So integration from whatever that T1 to T2 will give me delta T will be nothing but K by MC 2G, and this will be H square by 2. So H square by 2, where H is the total height. So clearly the change in the temperature is proportional to the square of the height. Hence the answer should be option B. Very good question. First part, you had to ignore the drag force for finding speed because drag force is small. But for the heat calculations, you have to only consider the drag force because the drag force is mainly responsible, contributes excessively to the heating. So the negative work done by that drag force is being consumed and lost as heat. So the magnitude of the work is the magnitude of the heat produced at every instant. Work done is force into displacement. Force is assumed kV square given velocity. Substitute from here, integrate, you get the answer. Isn't it a lovely question? Did you guys love it or not? Please tell me. Yep, perfecto, amazingo. Shall we go ahead to the next question on your screen? Here it is. Okay. So a large conducting slab having uniform surface charge density, this one is placed between the plates of a parallel plate capacitor. This is a parallel plate capacitor. You have placed that slab in between. Okay. Now, when you place it, the total charge density on the slab is sigma by 2. On the left plate, it is plus sigma. On the right plate of the capacitor, it is minus sigma. Assuming same cross sections, then the induced surface charge density on the conducting slab surface facing the positive terminal is how much? Basically, how much is the charge density here? How much is the charge density here is what they have asked. Okay, do I have a... No, I don't have a blank slate, so I'll have to draw it again, no issues. Okay, observe this, guys. So this is our slab, and this is our capacitor plate here, and this is our capacitor plate over here. Now, it is clearly mentioned, this is plus sigma, this is minus sigma. The total charge density is plus sigma by 2. So let's assume few things. Let's assume facing this positive plate, the charge density is negative sigma 1, and facing this negative plate, the charge density is positive sigma 2. Just some assumption, the induced charges that I have taken into account. Everybody fine till this point? Okay, these are the surface charge densities just on the left and the right plates of the slab. So, by simple logic, if sigma by 2 is the total charge per unit area, so think about it, the total charge per unit area, which is nothing but sigma by 2, should be equal to the sum of the charges on both sides divided by that particular area. That means it will be sigma 1 plus sigma 2. That's it. But this one is minus sigma, so minus sigma plus sigma 2. As simple as that. So if you want, you can write it as, therefore, sigma 2 minus sigma 1 is nothing but sigma divided by 2. So this is one equation that I get. Everybody till this point absolutely clear? Everybody till this point absolutely clear, my dear warriors? Okay, this much is done. Okay, now what do we do next? See, we can use this concept where Whenever you have a conducting slab, what happens? The field inside the conductor is 0. So we can choose a convenient point, let's say over here. So at this particular point, the net field should be 0. So the net field, electric field should be 0. So the field due to plus sigma, the field due to plus sigma will be this side. The field due to plus sigma will be towards the right side. So that field will be sigma by 2 epsilon naught. Then the field due to negative sigma will be left side. So I can say it will be minus sigma 1 by 2 epsilon naught. It will be towards left side. Okay. These two together will produce a field from the left hand side. From the left hand side should be balanced by, this is very important, it should be balanced. So this is basically the field, which is pointing towards the right hand side due to the charges on the left, due to the charges on the left hand side of this particular point. This should be balanced by the fields due to, this will be pointing this side, due to the charges on the right, due to the charges on the right side. So the charges on the right side will give a compensatory field to balance these fields due to the charges on the left side. So this sigma 2 will give a field here. So that will be nothing but sigma 2 by 2 epsilon naught this way. And this negative charge will give a field towards the right hand side. So minus sigma by 2 epsilon naught. That's it. So the total field from this side and the total field from this side should cancel out each other so that the net field here will be 0. As simple as that. Okay, fine, sir. Now what to do next? Now what to do next? Just solve this equation. A lot of things are getting eventually cancelled, like this, and this. So from here, what exactly am I getting? Just see. What exactly am I getting from here? I am getting sigma 2 plus sigma 1 is equal to, check this out, this goes over there. This particular thing will go over there and it will just become minus sigma plus sigma. It will become basically 2 times of sigma. So this is one equation, this is another equation. You just need to solve them simultaneously. Is that right? Perfectly fine. So this is nothing but your first equation, you can call it. This is your first equation. This is nothing but your second equation. So solve them, you will get the answer. What do we exactly need? We need the surface charge density on the conducting slab facing the positive terminal. That means we need sigma 1. So if we need sigma 1, let's subtract these two. So if you subtract these two, so 2 minus 1, the second equation minus the first equation. So how will it look like? So sigma 2 plus sigma 1, this is the second equation. Left hand side of the first equation will be nothing but sigma 2 minus sigma 1. This will be equal to, over here you have 2 sigma, which is the second equation's RHS, minus sigma by 2, which is the RHS of the first equation. Is that right, my dear students? Perfectly fine till this point. Okay, this much is okay. So what will this become, my dear students, on the left hand side? Sigma 2 cancel. Sigma 1 will come 2 times. So sigma 1 plus sigma 1 will be how much? This will be 4 minus 1, right? 4 minus 1 is 3. So 3 sigma by 2. Is that right? So this will become 2 sigma 1 is 3 sigma by 2. So sigma 1 will be 3 sigma by 4. So sigma 1 will be 3 sigma by 4, but it will come with a negative sign because remember that we had assumed only the surface charge density on the left plate is negative sigma. So on the left side, the charge density will be minus 3 sigma by 4. It is assumed only as negative. So that is the reason why the answer should be option D. That is why the answer should be option D. Is this absolutely clear, my dear students? So why it is minus 3 sigma by 4? Beautiful question. First part was conservation of charge. This total charge density or the total charge will be distributed on both the sides. Okay, they are unequal. I do not know how much it is. The second part was net field inside a conductor is 0, and the field inside or the field due to a surface charge is sigma by 2 epsilon. Just equate it to your vectors, guys. You shall get the answer. Is that right, everyone? Shall we go ahead? Shall we pakka go ahead to the next question coming up on your screen? Here it comes. Okay, beautiful question. If you are loving this session, make sure you are liking this video, yeah? And subscribe to the Vedantu JEE English channel. Yes, so that you will get more such sessions. Okay, focus guys on the class. Don't, yeah, deviate from the topic. Concentrate on the class. Okay, here comes the next question. Right, there is a particle of certain mass going in certain direction. This is the equation. F is minus 1 raised to p k x raised to n. P and n are positive integers. K is a real positive constant. The position versus momentum plot. Okay. The moment you look at this equation, forget all these things for now. What does this number tell you? Negative 1. What does this number tell you? Negative 1 raised to p, where p and n are basically positive integers. So, this number will be basically negative if p is nothing but an odd number, and this same number will be positive, like 2, 4, minus 1 raised to 2 square. That negative number will go off. It will become positive if p is nothing but even in nature. So if it is 1, 3, 5, minus 1 raised to 3 is negative 1, which is a negative number. And if it is even, it is positive. So this is only deciding whether this equation is positive or negative. Okay, so let's just ignore that part because that is completely useless for derivatives or integration. For now, we will figure out the sign later on. For now, let's just look at the, what if p is even, and then we can solve it. And then later on, we can make it odd number and then also solve it. Okay, so let's just solve. If p is basically, say for example, even, then what will happen? F will be equal to positive k x raised to n. Positive k x raised to n, because p is even means it will be a positive number. Minus 1 square, minus 1 raised to 4 will be a positive number. What is force? It is m times dv by dt, and the options had momentum versus the position plot. So we need to find a relation between the momentum and x, velocity and x. If you find, that is also enough. Okay, so this will be k into x raised to n. Okay, so now what do? We can write dv by dt as dv by dx into dx by dt. This k by m can be written over here. This is x raised to n. Dx by dt is velocity, so v into dv will be k by m, and this dx goes on the top, so it will become nothing but x raised to n into dx. This is the equation that we are getting. Obviously, we have to integrate this, and let's see what do we get after integration. So integral v dv is equal to k by m is a constant, keep it outside the integration, x raised to n dx, limits, let's say x naught v naught, this is nothing but this is nothing but v, this is nothing but x. I do not know initially whether it was at rest or not, so nothing is mentioned. So better start with some random value v naught and x naught. Okay, so this will become v naught square by 2, or v square by 2 minus v naught square by 2 is equal to k by m x raised to n plus 1 by 2 minus x naught raised to n plus 1 by 2. Sorry, not by 2, my bad. This will be by n plus 1, my bad. Okay, this will be n plus 1 minus x naught raised to n plus 1 by n plus 1. I don't know why I have this feeling. I want to make n plus 1. I want to make n plus 1 2, so that everything will cancel and maybe it looks like an equation of ellipses. If you use little bit of mathematical brain, you will realize that we are coming very close to the equation of ellipse or hyperbola, one of them. So if you notice over here, if I supposedly make n plus 1 is equal to 2, n plus 1 is equal to 2, then this will cancel, this will cancel, this will cancel, this will cancel. That basically means That basically means what? N is nothing but 1. So what happens then is I have v square minus k by m. This will be x square because n plus 1 is 2 is equal to k by m, or rather I will put v naught square over there, v naught square minus k x naught square by m. This is what I will get. Bring this guy left hand side, bring v naught square on the right hand side. Now, this whole number is a constant. This whole thing is a constant. So why not treat this whole thing as some constant like c? Bring this over here, you will get v square by c minus k by m, and this thing will again become a new constant. Let's say c1 is equal to 1. What is this? This is nothing but the equation of a hyperbola. Hyperbola. So if n is 1 and p is even means what? 0, 2 like that, it is a hyperbola. So p is even like 0, no it is not, p is even and n is 1, it is a parabola, wrong, circle wrong, ellipse, hyperbola. Hyperbola when p is 1, wrong guys. Hyperbola when p is even. So think about it, this whole thing came out like this when p is even. So what would happen if p is basically odd? If p is odd, this equation would have come to be exactly with a positive sign, means v square by constant plus x square by c1 is equal to 1, which is nothing but the equation of an ellipse. Which is nothing but the equation of an ellipse. So it's an ellipse when p is 1, like an odd number, and n is also 1. So n was 1 and it is basically odd. Odd means it will be like 1, 3, etc. So 1 is permissible. So hence p is 1 and n is 1, it is an ellipse. For hyperbola, p should be 0, 2, etc. and then n should be equal to 1. So beautiful question. A little bit of mathematical brain is needed, and they do combine such things, by the way. Yes, the concepts of conic sections, etc. can be combined into the questions. Okay. So don't think that maths is over in maths. No, they will definitely merge. That's what I said. They want to test how well you research it. It's not about just learning chemistry for the sake of it or physics for the sake of it. Whatever you learn in other subjects, other topics, suddenly something might be useful. That is how new discoveries, inventions, and research and development happens. Okay. So I hope you loved this question. All right. Moving on to the next question on your screen. Here it is. A particle of unit mass is released from the origin with some speed in the potential well. The potential energy is associated as so and so, where A and B are unity constants. Okay. So the minimum value of V naught in SI units for the particle to cross the well is closest to. Let me get a blank slide. Luckily, I have one. Okay. So see guys, first of all, let me write down the equation. That will be better. The potential energy associated with the well is A and B are unity constant. So A is 1. So it will be x square. E raised to B is also 1. So minus x square. This is in joules. Okay. When you have a potential well, what happens is, see guys, it doesn't matter what that equation is. All right. If you have a potential well, so this is basically a potential well. 1 second. This is basically a well. This is basically a well. So if you want to cross that well, if you want to cross that well, you should have some bare minimum energy. You should have some bare minimum energy to cross that well. You should have that kinetic energy, which will be at least equal to the potential energy at the highest point. So that is very important. So to find, so this is something which I can write down. So to cross the well, the kinetic energy must be more than or equal to the potential energy at maxima, at basically maxima. If you have that much energy, 100% you will be able to cross over that peak point. If you don't have enough kinetic energy to cross that potential energy, then you will stop much before that peak point and you will again come down. You will be trapped inside this particular well. You will keep on oscillating. So if you have enough energy, you can overcome that. Is this absolutely clear? Pakka? Okay. So let's see how does this come out to be maxima minima. So let's differentiate this function. So du by dx will be 0 for a maxima or for a minima. So du by dx means the derivative of this guy. So it will be d by dx of x square into e raised to minus x square. This should be 0. So uv rule. So therefore x square is the first function. Derivative of e raised to minus x square is minus x square e raised to, and derivative of this function is minus 2x plus the second function as it is into derivative of the first function, which is 2x. So this will be 0. So do not just cancel out x, that is not right. So it will be e raised to minus x square is common. I think even 2x is common. And from here I have 1, and from here I have nothing but x square. This is equal to 0. So if you want this to be 0, there are only two options. X is 0. Okay, x is 0, or basically 1 minus x square is 0, or 1 minus x square is 0, because e to the power anything cannot be 0. Okay, it can't be exactly 0. So these are the only two permissible options. Therefore x square will be 1. Therefore x is equal to plus or minus 1, plus or minus 1, and the next option is basically plus or minus 1, and next option is 0. So if you substitute these values, you will get the potential energy. So the potential energy will be at 0. At 0, how much will it be, guys? Just use this value. So it will be nothing but 0 square multiplied by e raised to minus 0 square, which is basically 0 joules. Okay. So at 0, it is 0 joules. Perfect. And over here, so potential energy at plus or minus 1 will be plus or minus 1 square into e raised to plus or minus 1 square. So how much will it be, guys? It will be nothing but e raised to minus 1. What is e raised to minus 1? It is nothing but 1 by e. Okay, just substitute it here. So this is the potential energy over here at 1 value of x, and 0, it is 0 joules. So this is obviously the minimum. This is obviously the maximum. So the kinetic energy that you have should be more than or equal to the potential energy at maxima as compared to the minima. So actually this is not absolute maxima that you should consider. So it is actually the potential energy at maxima minus potential energy at minima should come. Technically, the whole potential energy it should overcome. That is this much amount of energy. If it has this much amount of energy, if it has, it can overcome that well. So definitely we can do this problem now. So the kinetic energy will be half into m into v square, which is equal to potential energy at plus minus 1 minus potential energy at 0. Potential energy at plus minus 1 is nothing but 1 by e. 1 by e. At 0, it is 0. Mass is unit, so it is just half into v square, right? So therefore your v square will be 2 by e. Therefore v will be root of 2 by e. Okay, root of 2 by e. So I think the options are given in points. Substitute the value of e, you will get the answer as, if I'm not wrong, 0.85. Yeah, if you substitute the value, you will get the value of velocity as approximately 0.85 whatever units. Is this absolutely clear, guys? How to do this question? Yeah, brilliant question. This concept is very important, that your kinetic energy should be more than or equal to the potential energy at maxima minus potential energy at minima. So if that energy difference you are able to overcome, that means you will be able to cross that well. okay, or else you will be stuck. So this bare minimum energy is needed. So for that, we use maxima minima principle. I know we didn't check the second derivative, but we didn't have to only, because if the slope is 0 and this value is coming out to be less, this value is coming out to be more, most likely you can, I mean, think about it. This will be minima, this will be maxima. Okay, clear everyone? How to solve this particular question? Shall we go ahead, my dear students? Pakka? Shall we go ahead? Right? Cool. Okay, very good. Keep loving this video. And yes, stay strong, my dear students. Yeah, I know the questions are lightly on the higher side. That is how this paper is. Okay, so I want you to see these PYQs so that you are well aware before entering the exam hall, or else on the last day you will go and prepare and then you will be shocked. Okay, people prepare for this exam for a long time because they are very serious. A body of certain mass is subjected to some position dependent force. K1 and K3 are constants. The motion is bounded to a maximum amplitude. Motion is analyzed by neglecting the cubic term. Then the most appropriate condition to do it. The motion is analyzed by neglecting the cubic term. Then the most appropriate term is very interesting. Very, very interesting. Come on, guys. What are we supposed to do? So, if you neglect the cubic term, that means the force will be minus K1x. This is nothing but a simple harmonic motion. Why? Because the force is proportional to negative displacement. And if you want to neglect the cubic term, that means the value of K1x should be much, much larger than K3x cube. Yes or no? It should be much, much larger than K3x cube. So this is going to be very, very small. This is going to be large. X will cancel. So K1 should be more than or equal to K3x square. Now, if you notice, there is some inequalities over here. So from that, I got this idea that I should compare this. See, I have K1 and K3, right? Okay. In the worst case, what is the maximum value of X? This is in general. This is in general. So I want that even in the worst case, this should be true. So this value of X can be at max A only. This can be at max A only. So this is in the worst case scenario. In the worst case scenario. Worst case scenario. It can't be more than A. So if my, sorry, not greater than and equal to, my bad. Yeah. If my K1 is still much, much larger than this, then always I can neglect that cubic term, because this K1 has to be much, much larger than this term over here. This term can grow big because X can increase, but it can't increase beyond this because A is the amplitude of the motion. So therefore, I can say K1 by K3 A square is much, much larger than 1. K1 by K3 A square, or we can also do one more thing, or bring that K1 below K3. So I can then say that 1 is much, much larger than K3 A square by K1. Yes, K3 A square by K1 is much, much basically smaller than 1, which is the D option, I believe. Just check it out. Yes, it is the D option. Perfect. Can you see that? Either you can shift K3 below with A square, or you can shift K1 below. One and the same thing. You can get either of these relationships. So I can see option D is matching over here. Is that right, everyone? Loved the question? Yes or no? Just simple manipulation, but this manipulation is only that crazy part. Yes, that manipulation only is that crazy part. Cool. So let's go, guys, to the next question on your screen. There is a rigid body which is rotating at 3 radians per second about an axis passing through points A and B. Oh, interesting. The coordinates are given. Assuming all quantities are in SI units, the instantaneous speed of the point P with the coordinates. Wow, this is completely three-dimensional vector analysis and all of that. So luckily I have some empty slide over here. So think about it like this. If you have some random axis and these are the points. Let's say this is point A and this is point B, and then you have considered, let's say, some point P over here. This is basically some point P, and about this axis AB there is a rotational angular velocity which is given to be 3 radian per second in magnitude. So this is my position vector, let's say r. Then the velocity, because you will be going in a circular path, right? You will be going in a circular path. That particular velocity, what is the formula for that, my dear students? What is the formula for that particular thing? Can you remember? Yes, it is omega cross r. Do you remember this? This velocity is nothing but your omega cross producted with r. Lot of people forget that there is a cross product. Usually we deal with scalars omega r every time because omega is perpendicular to r. But what if it is not perpendicular? What if it is in 3-dimensional? Axis is not along y, z standard ones. So then you have to use this cross product rule. So somehow I need to find omega, somehow I need to find r. If I do that, my job is done. So if I have to find velocity, I have to do this, what do you say? This determinant solving. That's all. So this determinant solving. So I will just put I, J, and K over here, and then that will be nothing but I cap, and I will have this minus J cap, and then I will have some K cap over here. Solving this, you will definitely get the final answer. But the problem is, what is R and what is omega? So that is the crazy part. So how do we find that? So I have an idea over here. Because I know the points A and B, I can find the vector AB, and from that I can find the unit vector over here. Unit vector over here, let's say I call it n hat. And that n hat with the magnitude gives me the omega vector. Okay, interesting. So how do I find n hat? So for that, the vector AB will be, vector from A to B will be 1 minus 0, x2 minus x1 I cap plus y2 minus y1, that means 1 minus minus 1 j cap plus 3 minus 1 z2 minus z1 k cap. So this will become I cap plus 2j cap plus 2k cap. So that is vector AB. So therefore, what is that unit vector n hat? That unit vector n hat will be nothing but the vector AB by the magnitude of it, So it will be I cap plus 2j cap plus 2k cap, whole thing divided by root of 1 square plus 2 square plus 2 square. 4 is 8 plus 1 is 9. Just check this out. Everybody till this point absolutely clear? Just check this out. It is nothing but root of 7. Everyone? Yes. 3. And then this is nothing but 1. And this is nothing but, okay. All right. Perfectly fine. Till this point, I think everybody is able to see this. Cool. Okay. So once you get this, just see how much is the value. It will be nothing but 1 by, this is nothing but 3, and this will be I cap plus 2j cap plus 2k cap. Okay, perfect. So this is your n hat. This is nothing but your n hat. All right. Now, if you see the options, okay, they are something like this. Okay, fair enough. We'll just leave it like this because 4 plus 4 is 8, 8 plus 1 is 9, root of 9 is 3. Okay, we'll just leave it to there. Now, what will be omega vector? Omega vector will be the scalar value into n hat. So, scalar value is 3. N hat is nothing but 1 by 3. And this is nothing but I cap plus 2j cap plus 2k cap. That's it. So 3 3 cancels. So therefore I will get omega vector as I cap plus 2j cap plus 2k cap. So omega vector I have got I 2j 2k. I 2j 2k. So I 2j 2k. I is 1, 2j is 2, 2k is 2. All right, perfect. What is the value of r. So the position vector r with respect to, let's say, the point A, so it will be again x2 minus x1, so it will be 4 minus 0 I cap plus 6 minus minus 1 j cap plus z2 minus z1, that means 7 minus what is it, 1 k cap. That's it. So this will be 4 I cap plus 7 j cap plus 6 k cap. Just check this out. Perfect. So 4, 7, 6. So 4, 7 and 6. Do the math and you will get the velocity. But the question is find the speed, right? So once you get V bar, just find the modulus of it. Just find the modulus of it. Check it out if the answer comes out to be 3 units. Check it out if the answer comes out to be 3 units. That is the final way. Okay. So this thing everybody knows how to do it. But till this part, how to get there, that was the tricky part. That was the catch in the problem. So we found out this axis itself, the vector AB, from that the unit vector, from that the omega vector might be only till here, who knows? Omega vector might be only this much. Omega vector might be only this much. So omega cross r gives me the velocity. R we found out simply x2 minus x1i, y2 minus y1j, z2 minus z1j k cap. Is this absolutely clear, everyone? Shall we go ahead? Pakka? Cool? All right. So let's go. Let's go. Let's go. Let's go. Let's go. Let's go to the next question. Wow, what is this? We have solved these kind of questions in maybe mains or even advanced level where you rotate a liquid and it forms a parabolic surface. And there is a curvature which is created. When you rotate, the centrifugal force pushes the liquid towards the periphery. There is a beautiful curvature which is formed. And the tan of the tangent drawn, angle made by the tangent drawn with the horizontal line makes an equation omega square x by g. The radius of the curvature of the surface is much larger than x. Okay, so we have to assume that. So what is the options? So I think one thing is very clear, it will make a parabolic surface. So 100% this will be true, this will be wrong. But to show you why it is a parabola, let's see if I have an empty slide. Yes, we have an empty slide. See guys, over here, tan theta is nothing but omega square by g into x. Tan theta is nothing but the slope. The slope has a formula dy by dx. So dy by dx is omega square by g into x. Rearranging the symbols, so dy will be omega square by g x into dx. Now comes the funny part, which is integration. So integration starting with 0, 0, going to x, this will be y. So if you integrate it, you will get y minus 0 is equal to omega square by g, and this will be x square minus 0 by 2. So therefore, you can notice y is equal to omega square by 2g into x square. Clearly, it is a parabola. Clearly, it is a parabola. Definitely, it is a parabolic surface. Y is proportional to x square. It is not proportional to x raised to 4. What about the other options? I'm guessing the actual question should have been which of them are incorrect. Then I think incorrect options would have been asked. Then our answer A is incorrect. So option A is definitely wrong. Focal length and angular speed. We'll check that. If it is correct, then that what I have assumed is the right question. Else, maybe only the correct option is asked. I don't know. Maybe we'll see, because I have a feeling that the focal length and the angular speed may come out. We'll see. So if you rewrite it in the proper parabolic equation form, x square will be equal to 2g by omega square into y. And if you compare it with x square is equal to 4a into y, yes, the standard form of parabola equation. So clearly one can see that 4 times a is equal to 2g by omega square. Therefore, a is nothing but g by 2 omega square, where A is nothing but the focus. So the focus is G by 2 omega square. Yes, the focus is G by 2 omega square. Absolutely correct. Absolutely correct. And what is the radius of curvature, they have asked? See, we all know this fact that radius of curvature is 2 times the focal length. So 2 times the focal length is G by 2 omega square, which means it is G by omega square. G is 10, omega, what they have assumed? 2. So 2 square, which is 10 by 4, which is 2.5 meters. So the radius of curvature for a mirror is 2 times the focal length. If I use it, I get it as 2.5, which is also correct. So the incorrect option will be A. So other options B, C and D will be absolutely right. So do not mark them. Yep, it is perfectly fine, guys. B, C and D. Okay, B, C and D. Isn't it amazing question? Where you have to relate. Again, I said conic sections, lot of times they are combining. Yeah, conic sections, they are combining it many number of times. Okay, be careful about it. Cool. So let's move to the next one on your screen. In an adiabatic compression, the pressure increases K times. D is the typical distance. Then what is the ratio D1 by D2? As K raised to alpha, the value of alpha is how much? Oh, interesting. First thing, it is adiabatic process. How is the pressure related to the distance? Maybe not directly, maybe indirectly, maybe related to the volume, and volume is related to the distance. So we know for adiabatic process, PV raised to gamma is a constant and it is a monoatomic gas. So gamma will be 5 by 3. So P1 V1 raised to 5 by 3 is equal to P2 V2 raised to 5 by 3. The pressure increases to K times. So P1 and, or if you want, you can just write V1 by V2, the whole raised to 5 by 3. Is that right? Will be P2 by P1. And P2 by P1 is basically K as per the given equation. Now, if you want, I can write V1 by V2. Okay, we'll just leave it to that. We'll see what to do about it later on. Now, it is mentioned the distance between the atoms is D and it is changing. How is that related? See, the volume of a gas will be directly related to the number of molecules, and imagine the molecules having certain distance between them. Let's say D, 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 D. If you make a cube, the volume of a cube will be D cube. Just visualize this. Okay, just visualize this. If I have the molecules in this particular format, this is a D, and the molecules or the atoms are over here, right? Are over here. So if I have a big whatever container like so, if I have a big container like so, this is that research part which you have to think. Imagine many such cubes will fit. Many such cubes are going to fit. And the number of cubes will be proportional to the number of molecules and also the volume of each small cube. So into, I would say, the volume of a small space which you are considering, which is itself d cube. This is number of molecules, this is the total volume. So volume is proportional to d cube indirectly. So V1 by V2 will be nothing but d1 by d2 whole cube. Volume is directly proportional to d cube. So V1 by V2 is directly proportional to d1 by d2 whole cube. But this whole thing has to be raised to 5 by 3. This is equal to K. Of course, now this 3 gets cancelled. So d1 by d2 whole thing raised to 5 is K. So d1 by d2 Okay, so d1 by d2 will be k whole thing raised to 1 by 5, which is k raised to 0.2. K raised to 0.2. So I think it should be B option. Yes, perfectly fine. B option is the right answer. So this analysis was very, very important. Okay, this analysis part was very, very important, where the total volume is how many molecules are there, that many cubes will be there into volume of each such small space, which is itself D. Beautiful question. Did you love this? Yep. Shall we go ahead, guys, to the next one? Shall we go ahead to the next one coming up on your screen? Here it is. Consider a Young's double slit experiment with certain pinholes at coordinates so and so, and the screen here, light of wavelength is used. The shape of the fringe is a hyperbola with eccentricity. Now, this question is one of the most difficult questions if you do not know the formula. If you know the formula, it is very straightforward. See, simple uh, thing if I tell you in simple ways, along the z axis, basically, x, this is the y, is this z. Okay, along the z axis, there are two slits, okay, at a and minus a. So one is over here, the other is over here. So this is slit number 1, this is slit number 2. Okay, the separation between them is basically 2 times of a. Now the screen is at y is equal to h on the y axis. So yeah, that is how it is. Z axis over here, the screen is on the y axis. Okay, so you will see that there will be some kind of hyperbolas which are formed. Yep, so just have to visualize this. So there is a screen at y is equal to h over here. So if you have a screen, these hyperbolas that are formed, how do I show you? It's very difficult, guys, to show you, but these are the kind of hyperbolas which are formed. These hyperbolas are nothing but these hyperbolas are nothing but the locus of points with a path difference. Since we are interested for the second bright maxima, so there the path difference will be 2 lambda. That is the first thing. Now there is a direct formula for eccentricity. If you know it, it is good. If you don't know it, you have to sit and derive the equation of the hyperbola by taking any point on that hyperbola, some coordinate, and use Pythagoras, then use binomial approximation, then rearrange the equation, get it in the parabolic form, compare it with the hyperbolic form, compare it with the hyperbola's equation, and then eccentricity formula, and then use that approximation and then get it. So it's a crazy, crazy derivation. If you know it, great. If you don't know it, gone. And best thing is, if you know the result, it is nothing but the distance between the slits upon the path difference. Now the distance between the slits is basically 2a, and the path difference is basically 2 lambda. So it just comes out to be a by lambda. A by lambda is option A, I believe. Yes, it is directly A. So if you know this formula, it's good. So better remember it. Otherwise, I think I have put that derivation somewhere. Yes, I put this derivation just for you. It starts with, finding the general point part difference in terms of Pythagoras theorem, then using some assumptions and then going with it, and the eccentricity formula. This is that hyperbola's equation. From that you get eccentricity. So it's a very lengthy thing. Obviously in the exam you cannot do this unless you know the formula before. Okay, so this was one of that question which can suck away a lot of your time. You think it is simple, but it is not simple. Okay, cool. Anyways, going ahead, just letting you know that these kind of questions you might have to let go unless you know the question. Okay, Certain things you can do it. See, I'm not saying all the questions you need to know the formula. You cannot do that, because then what is the research in it? The point is, you need to know which questions to leave. Obviously, you cannot sit and solve all the questions, right? Moving on. Assume that the Bohr's theory applies and the number of protons and neutrons in the nucleus is approximately same. The maximum atomic number for a hydrogen atom is close to number of protons, neutrons in the nucleus same. Okay, the maximum atomic number. So why would there be a limit on the atomic number unless something which is exceeding some and going into some unrealistic value? One of that could be energy, radius. Radius does not have unrealistic value. Energy, well, no. But what about speed? What about speed? What if speed of the electron exceeds the speed of light? Then if you use Bohr's model, then there will be a limitation to that also. What is the formula for the speed of a Bohr's electron? You can use our standard equations, which is L is equal to NH by 2 pi, where L is nothing but mvr, that is NH by 2 pi. And you can also use this equation, which is force is equal to m into AC, which means m into v square by r is equal to 1 by 4 pi epsilon naught ZE into E divided by r square. Using these two equations, this and this, you get the equation for velocity. You can eliminate r from both of them and you get the equation of velocity. Yeah, you get the equation of velocity. What is velocity proportional to? It is proportional to z by n. It is basically proportional to z by n, if you remember it correctly. And the remaining terms come out something like this: E square by 2 epsilon naught h, I think. Yeah, 2 epsilon naught h. Okay, this is n, this is h. So 2 epsilon naught h comes in the bottom. Okay, E square comes on the top. Now, if you don't remember it, I mean, that's okay. You cannot do anything about it. You have to sit and derive it using these two equations. So, in the limiting condition, V value, I think, will be the speed of light. So, if I use that speed of light, so what will happen to Z? And we will take the ground state. So, in the ground state, it will be basically 1. So what will Z be equal to? Let's see. Velocity is c. This 2 will come, epsilon naught will come, h will come, n is nothing but 1 divided by e square. Oh, so that's it. So speed of light is 3 into 10 to the power 8. Okay. 2 into epsilon naught is 8.85 into 10 to the power minus 12. And h is nothing but 6.6 into 10 to the power negative 34. The whole thing divided by 1.6 into 10 to the power minus 19, the whole square. So they have just made the calculation a bit longer, but if you do the math, okay, for Z, you shall get the answer. Okay, just see if you are cutting it close to 137. This value of Z comes out to be 137. This is very important. For the maximum atomic number, the velocity has to be lesser than or equal to the speed of light. Has to be lesser than or equal to the speed of light. That thing should strike your brain, that why would it be limiting? Because in Bohr's model, what and all is there? Angular momentum. N does not have limit. N can be 1, 2, 3, 4, 5, 6, 100, 1 lakh also. Angular momentum that way has no limit. It feels like that. Then energy can be maximum 0. That means the electron will be free. How is that related to atomic number? No. The only way, I mean, something can be restricting in nature is that speed of light. So it was related to relativity concept, this particular question. You cannot exceed the speed of light. So speed of the electron has to be less than c. And from that, we get this answer. So if you don't remember it, use these equations, eliminate r and get speed. Okay. So you get the answer as 137. Oh, that was the last question. We have some homework questions. This is first homework question. Take a screenshot. The answer is there on the next slide. Along with the solution, you will be getting the PDF. Okay, don't worry about it. And is there one more homework question? Yes, this is another homework question. You can do this easily. This is fairly fine. finding the density of nucleus is approximately how much. This can be a standard question as well. Okay. Anyway, so I hope you have taken the screenshot. Answers are there on the next slide. Now, let me know in the comments if you enjoyed this session and you want more such sessions, because it has definitely provoked your thinking. And this is not like JEE Advanced. You would have realized it by now, isn't it? So it's very different. If you want more sessions, your likes, your comments are going to matter. Your captain Shreyas sir will do it for you. Okay. Bye bye. Signing off. This was your Cap 2 Shreyas, and we'll be meeting soon. Yeah. Thank you for liking and thank you for subscribing.